Monopolies. It's a word we all hate to hear, whether it's around the family table or in one of our favorite business sectors. And it's a concern that may be coming to the cloud, but Kubernetes could save us. And Laurent is here to tell us how.
Thank you, Darren. Let me share my screen. Let's see if that works. Here, share screen. Do you guys see it?
Yep, we've got the looping screen though. Is that the correct screen you want to show?
Yeah, it's coming. Okay,
Okay,
here we are,
fantastic.
and I have some slide. Okay, here we go. So thank you, Darren. So I'm going to talk to you about a subject that is very dear to me personally. It's about the cloud monopolies and what we can do about this. Thanks to Kubernetes, I'm going to show you some. So first, I'll tell you what is the cloud monopoly, why it really bothers me, and then I'll show you some way of breaking that monopoly with Kubernetes. It's a little bit of a prototype that I will show you. So I'm going to try to deploy an app across two different cloud providers, and then use some cost arbitrage between the two cloud providers to see how effectively you can deploy an application that is free to move from one cloud to another. It's a little bit of a prototype, and I really want to show you the app itself, not a slide. Hopefully the demo gods will be with me when I show you this. Um, so um, it's a pleasure to speak to you. So my name is Laurent Gilles. I'm one of the founder of Cast AI. It's a company that is actually in Lithuania, in Vilnius, and in the US, Miami. And I live in Miami, but I'm in Europe right now. And I look forward for next year to have this conference face to face. I'm sure a lot of people wish the same. Okay, cloud neutrality and cloud monopolies. Why? What is it? Why? This is something that is concerning me. So it's the realization that the cloud industry is a multi-billion-dollar privately owned and non-regulated infrastructure that is essential to the modern internet economy. Yes, that's what the cloud industry means. And frankly, that should freak you out because it freaks me out myself. And here is why. The cloud is a fortress. When you think of the cloud, you're always thinking of AWS, Google, and Azure, and a few others like Ali Cloud, IBM has one, Oracle has one. So the cloud is a fortress where we host our business, and there are only 3.5 fortresses. And I'm being generous here. I say 3.5 because there is the one that we know by heart, the one we love and hate at the same time. So starting by Amazon, that is the distant number one. Azure and Google are probably fighting for the number two position. It depends how you look at them. Sometimes Google is great with Kubernetes and very large. Another time Azure is more important than Google in revenues. But these are the three major cloud providers. And then the rest of the world is the zero point 0.5. So that's, IBM has one. Oracle has a cloud, which is actually pretty good. OVH is another one in Europe, and there are many others, small or medium-sized cloud providers all over the world. But if you think of this as an enterprise and as a business, there really is only 3.5 of these where you can host your business. And the landlords, meaning the owners of this cloud provider, well, they may deny your protection. I mean, think of this as if you want to host in Ali Cloud. Ali Cloud is managed by a company that respects some traditions that are maybe not the same as what AWS or Google will do, in the sense that you can use Ali Cloud, but you don't really know if what you have in Ali Cloud may be shared with others. So all this means that the landlords have a strong ownership of the rules. It's not regulated, so they can do whatever they want, and they may deny their protection, or they may increase their prices. And we just saw this last month with Google Cloud that increased their price on some storage services by 50%. And I think I'm concerned by this because I think we're gonna probably going to see a lot more inflation in cloud prices. But guess what? A big piece of the cost on the cloud providers is energy. And energy is only going into one direction right now, which is up and expensive. So they may increase their price. They are actually free to do whatever they want in their prices. And it's not like you can move quickly to another fortress. I mean, think of this as if you're on if you're on Google, let's say, because they increased their price last month and you are not happy with the fact that they are not charging egress for storage between region, well, what do you do about it? You know, if you tell Google, well, if they do this, you'll move away from them, they're going to tell you good luck, because it's not easy to move from one cloud provider to another because you have to learn everything again. And it's not like you can port your application, except maybe if you use Kubernetes. And that's the reason why I will show you an example with this. But it is hard to move from one cloud provider to another, even if you don't like it or you don't like what one of them is doing to you. So we live in the world where the control of the market for cloud services is consolidating, and a handful of tech giants, these are the three cloud providers, they control the market for cloud services. It's consolidating. There's only three winners by far over everybody else. And frankly, they have a lot of money and enough money to blanket the globe. So this industry is effectively became a monopoly with three very large operator and zero point 0.5 for the rest that control the market. They will decide whether you can go on their cloud or not. Sometimes it's a market decision, other times it's not a market decision. And whether you choose one, you are at the mercy of that. And if you don't like them anymore, or if you feel that their prices are too high, or if they just increase their price, like what happened last month, there's not a lot of things you can do about it. That's why this freaks me out personally. There is no cost arbitrage. There's virtually zero competition. Let me say why. Yes, if you're a new customer, you may be able to play, especially Amazon against Google, and they have teams at Google that knows how to handle that, and they will do a special pricing to you, or they will explain why their solution is great. And frankly, they're all great. The Google, Amazon, Azure have great product. But once you select it, you are pretty much done, unless you use Kubernetes. But you're pretty much done in sticking with them. And frankly, that makes me worried, especially in the time of inflation and recession. Inflation means the price will go up. Recession means your revenue may be under pressure, or your customers may disappear, or may request less product from you. So you have these two aspects that are going in the wrong direction at the same time, which is the prices are increasing and maybe your customers will not do very well. And that in turn makes you, reduce your cloud surface or continue to spend your cloud cost with less revenues to offset it. So it's not a great thing to do. But there is hope. And this is where the use of multi-cloud comes in. And this is the reason why I want to talk to you about Kubernetes and what you can do using Kubernetes to at least place some aspect of pricing arbitrage between cloud providers. And let me show you why. So when I say multi-cloud, it's a little bit a complex definition, but for me, multi-cloud means it's a process-oriented multi-cloud. That means that we are binding application and data together through abstract processes, that's Kubernetes, that can span across multiple cloud locations. So think of this as my multi-cloud discussion is, well, I wish that the same application could live at the same time on, let's say, Amazon and Google. That's what I call multi-cloud. If I do this, then suddenly this application may use AWS for some compute, may use Google for others, and may actually decide in real time which places it wants to use based on a cost arbitrage. It could also be based on disaster recovery. If one cloud goes down, you still have the other. But my example I'm going to show you is based on cost arbitrage. So think of this as, and that will be my demo or my prototype, is let's see if we can deploy a Kubernetes application, so containers, deploy to an engine that is smart enough to understand in real time what this application needs in terms of compute and memory resources, and make a decision in real time of where to put these or where to use these resources of compute and memory according to the pricing of the moment. And if you do this, you effectively have solved, or at least are benefiting, you can benefit from the pricing arbitrage that you may see between one cloud and another, because now your application is free to move, or at least to select the right compute quantity in one place over the other place, doing this with no outage and doing this automatically. So that's the challenge, and that's what I'm going to show you with Kubernetes. Before I go there, I want to tell you a little bit of WTF is multi-cloud and why multi-cloud is a possibility to break the monopoly. The first thing I did is we I have a team of scientists that started to look at, if I use different compute capacity, and one is on Amazon and the other one is on Google, how is the latency going if I do this? So if you use Amazon on US East, you're fine. They're almost, these machines are on the same network. Yeah, you can use different zones, but pretty much these machines are very much very close to each other. But maybe you can do the same with Google, and between Google and Amazon, actually the distance is not that far, and that's what I call the 5 millisecond Goldilocks. I'm going to show you an example of this. So this is a Jupyter book we did, and this is a study we made. Let me make this screen bigger. That looked at the latency between cloud providers in certain region. So I'm going to look at Frankfurt. So Frankfurt is nice because it's very centrally located. And let me, Frankfurt here. Let's go to Frankfurt Google Cloud. And what this does, so this Jupyter Notebook does, it compares the all-to-all latency between machines, between compute instances over a long period of time between these cloud providers. And it says the following. Well, in Frankfurt, you have DigitalOcean that is about 2.9, or let's say 3 milliseconds away from Google Cloud in Frankfurt. That's great. Then you have Azure that is 3.4 milliseconds away, and then you have AWS that is 3.7 milliseconds away. Think of this as if you can deploy the same app across Google Cloud and any of these 3 other cloud providers, you effectively are fine because these machines are very close to each other in milliseconds. And in the Kubernetes world, we consider that 5 milliseconds is a good number, meaning containers can communicate and can feel that they are part of the same cluster within a 5 millisecond connection between each of them. So that's the realization that, yes, there is a strong possibility, in fact, that you can, if you can deploy on Google Cloud and any of these 3 or all of them cloud providers, you effectively have compute machines that are so close to each other that the latency does not impact, at least on the Kubernetes world, the communications between containers, and that means it will work, most likely. So we did this study for the 5-second Goldilocks. We did it all over the world, and this is here. This is another example. This is Brazil. So Brazil is also, so this is Oracle Cloud. Brazil is within 5 milliseconds of Amazon, Google, and Azure, which means all the 3 are within 5 milliseconds of each other, and including Oracle Cloud, in this case in Sao Paulo. And this is a map. So we did a heat map of all the regions that are not too far away from each other, and you can tell there is the usual suspect. So there is a big blurb for EU Central, this centered around Frankfurt, but you also have another one in London, Paris, Brussels, that is within the 5 milliseconds. You have the Sao Paulo one I just showed you earlier. You have multiple one in the US. So you have the US East. You have another one in Toronto and New York that is not too far. And of course, you have the US West. But you have also countries where cloud was typically, or internet that is was typically a little bit more expensive. There's a big one centered around Mumbai in India, where you have all the cloud providers. You have Tokyo and Osaka. Each of them are very good clusters with all 3 cloud providers, including South Korea, all 3 cloud providers together. And the most expensive is probably Australia, at least from an internet perspective, where you have Sydney with 4 cloud providers. And I assume that's probably Oracle, Azure, AWS, and Google. So This is a realization. Oh, and of course, Singapore is the same. So the realization that yes, there are 6 or 7 locations all over the world where you can effectively use machines in these places, and the machines will communicate as long as you are using Kubernetes. So that's why the Kubernetes world is important. As long as you're using containers and they are 5 milliseconds from each other, you effectively can deploy in more than one location in these this country in these global regions. The other things that we do that the other aspect of our investigation was on pricing, and the question was, well, if I can use Google and Azure or Google and AWS in Frankfurt, does it make sense from a price perspective? Is there enough price difference between AWS and in one location so that it makes sense to break the cloud monopolies and use both of them at the same time in the region where I operate? And we were very surprised with this. So I had a screenshot here of 2 machines. These are actually the very same machines, the same processor, almost the same. It's almost the same processor. It's a 4-core machine. The one on Oracle has a little bit of more memory. The one on Google Cloud is a typical 4 CPU and 4 gig of RAM. So it's an E2 high CPU 4, very popular machine on Amazon. And on Oracle, it's called VM standard.e2.4. That's what Oracle call these. They are both in US East Ashburn, which means, or in Virginia, which means they are, yes, within this 5 millisecond difference. And yes, the Oracle machine is more expensive by around 10%, or actually a bit more, like 14% more expensive for Oracle. But look at this. The performance of Oracle machine is twice the performance of Google machine. So that means that you have about twice more quantity of compute per dollar on Oracle than you have on Google, even though these 2 machines are very similar. And this performance is very stable. It's 99.92% or 99.78% stable, meaning you have the same type of machine, apparently. The Oracle is a little bit more expensive, but the Oracle machine gives you twice the amount of compute that the Google one gives you. And that says to me that yes, there is a difference of pricing. In this case, the difference is very hard to find. It's a difference of performance. So you have twice more compute for 15% more pricing. So you have a 30% advantage to use the VM standard machine on Oracle in Virginia compared to using the one on Google. So that sounds like, yes, there is an arbitrage of prices, and it shows. So here I'm going to show you the real thing. Don't have a lot of time, but I will show you the real thing. So I deployed the same application on Google and on AWS in the same region, and I'm going to show to you that I really am doing it. So I am deploying the same application and apply here. Oops. So I'm just deploying the same app. This one is on Google, and this is my terminal for AWS. I'm deploying the same application on AWS. Application is being deployed right now. This is Google. You can see the pods are coming up here, and then the one on AWS, the pods are coming up here. Okay, so the application is being deployed on the machines that are in this cluster. The cluster are exactly the same. They have 6 VMs on each side. This is the one on AWS. I have 6 nodes, and this is the one on Google. It has also 6 nodes. And then this tool is giving you, this is a tool for my company, but I'm using it only as a demonstration. This tool is giving you the cost to run this. So the cost to run this app on AWS, if I turn on Spot instance, is around $420 a month. It uses 12 CPUs, exactly the same machine. This is a popular machine on Amazon, M5.large. So I spent $420 a month to run this. And on Google, the same application using the exact same kind of machine cost me $293. So think about this. If you have the chance to use Google over Amazon for this particular region at this moment, it's going to cost you a lot less. And then to make sure that the same optimization would run on Google and Azure, on Google and on AWS, I'm going to run this simulation that says if I were using Spot instance and if I was right-sizing this app, I would spend on AWS $147. If I do the same optimization, so I use Spot Instance and I optimize on Google, Google comes at $49. So remember this, same application, one run on AWS, it costs 147. The one runs on Google, it costs $49. It's the same app. I deployed the same application on the same type of CPU using standard public pricing of both cloud providers. So that's tell you, yes, there is a lot of pricing arbitrage you can do here. And this is what this is showing to you here. Here it's without Spot Instance, but even without Spot Instance, the AWS one costs 167, the Google one costs 108. Now, in some other case, it may be the opposite. It may change over time, but this is a good demonstration of, yes, there are a lot of different pricing on the cloud provider, even though we all think these machines are relatively similar. Sometimes they even have the same CPU, but they don't cost the same. And that's an example between Amazon and Google. And this is a real one. Like I deployed it in front of you guys. This is a screenshot I took earlier, but the applications is the one I deployed in front of you guys. So yes, it shows there are some optimization opportunities between cloud providers. But let's try something even more interesting, where I'm going to create a cluster. And in this case, the cluster is going to span across more than one cloud provider. So this is a little bit of the science fiction part and the prototype. The idea is I'm creating a cluster. I'm using open source tool to create the cluster. The cluster is going to use my account on Amazon and my account on Google. So it's one cluster that will have a number of machines of nodes in this cluster that will be distributed between these two cloud providers. And then, so I just created this earlier this morning. And then I'm going to deploy the same application you have seen, and we're going to see how the engine is going to select one cloud provider over the other based on pricing difference. So the science fiction part here, or the prototype aspect of this, is it really is a cluster that span across more than one cloud provider in the same location. And here is the cluster. Let me show you all the clusters. So here's the cluster. It's called DevOps Pro. The cluster span between AWS and Google. I use my tool to do this creation. So the cluster span across AWS and Google. If I click on the cluster, right now I have 0 node into it. I didn't deploy anything. Sorry, I have 2 nodes, but I didn't deploy anything yet. These are just the daemon set nodes and the resource that AWS add into it. So the cluster is empty for now. And the cluster by default has been deployed on between AWS and Google, but because there is nothing deployed yet, it uses only one of the two. And in this case, it uses AWS. And it did create this is the smallest cluster I can create myself, which is an M5A.large. I think it's a 2-core machine. A means AMD, so it's extremely cheap cluster so far. One node is the master node, and the other one is a worker node. There is no application deployed on this application. But this cluster span across Google and AWS. They are connected to each other over a VPN. There is a master node that happens to run on Amazon that have access to compute resources that are either on Amazon or on Google or both at the same time. And this master node is connected to my account over VPN across these two cloud providers. So let's deploy the app and see what happened here. Go back to my terminal. I created this earlier. This is my cluster DevOps Pro. Let's clear this thing here. And I'm going to, yes, I'm in the right folder. I'm going to deploy the same application, kubectl apply f dot. And just to show you this application really exists, it's here. And this is actually the open source application that Google used for demos. It's called the Boutique app. It's very famous or very popular with Google, especially for Google CentOS. So Google used that as a demo of an application using Kubernetes. It has about, this has a 50 replica, but there are many, many different pods, many different workloads. that have deployed on this for this application. It has deployed now, so the kubectl was ready, was finished. And what this means is there are so many pods that I actually don't have enough space to run this. Remember, I have only my 2 nodes. They are on AWS right now. And I have a lot of pods that are unscheduled because they have no place to run. I need to add a new node to do this. And here you can see my engine, so the smart autoscaler that I'm using, is creating on the fly a few new nodes for these pods that are unscheduled, that have no place to run. There's 106 pods, 43 have found a place, but 63 didn't find a place yet. That's why these 2 new nodes are being created. What is super cool here is the new nodes created are on Google. So the N1 high CPU 8, it's a Spot instance, it's on Google, and the E2 high speed CPU 2 is a popular machine, also on Google. One is on demand, the other one is a Spot instance. Why a Spot? Because my application is Spot friendly, and I actually told the cluster that I can use Spot instance when it's necessary or when it's possible. The question now is, why did I select, or why did the engine select this N1 high CPU 8 on GCP? And let's look at this. So this is an 8-core machine. This should be here. Yeah, it's an 8-core machine, as this number is not available yet, with about 8 gig of RAM. It's very popular machine, N1 family on Google Cloud. And this one here is a standard 2-core, I suppose. Yeah, the number is not here yet. 2-core, 2 gig machine on Google. So let's see why it did this. And I will assume that it probably selected these machines because they are cheaper on Google compared to their AWS equivalent. So remember, the cluster span across these 2 locations in the same place. I forgot if it's Frankfurt or Virginia, but in the same location, I deployed a cluster that is aware that the cluster can use AWS and GCP. And the autoscaler of this cluster is a smart autoscaler that will select the machine where it is the most appropriate in size, but where it's also the lowest cost possible. And so let's look at this and let's see if the N1 high CPU 8 is effectively cheaper. Let's find out the price of these on Google and compare this with the price on AWS. So I did this here, open my spreadsheet. I assume I didn't know that it was going to be an N1 high CPU 8, but earlier this morning it was this one. So price of Spot instance change frequently, so it may not be the same tomorrow. But this morning it was also a N1 high CPU 8 when I tried. So in the pricing of this guy, this is the N1 high CPU 8. Let me check to make sure. Yes, N1 high CPU 8. And so I go to pricing, and that machine cost this price, 0.059. Now let's look at the same on AWS cloud. So on AWS, there is no machine that have the same 8-core and 8 gig of RAM, but I think the closest one is probably 8-core and 16 gig, which is a C5 family. And so, and I forgot which one it is. It's probably the 2X. Yes, C5 2X is also 8-core. So that's the type of machine I need to look at. So the pricing for this on Google was 0.05. And the pricing for a C5 2X large, this one here, that's not the price, I think it's here. C5 2X large, the spot price is this price. Let me share it's this column. Yes, it's this column. So, and of course I lost it now. C5 up here. So the pricing is 0.08 cents per hour. So you compare this with the same machine on Google, which is 0.05, or say 0.06 on Google and 0.08-ish on AWS. That's a 30% difference between them, about 30%. I think a little bit more than 30%, 1/3 difference between Google and Azure. So effectively, Google and AWS. So my autoscaler selected a Spot instance on Google because it costs only 0.05 or 0.06 over the same on Amazon because the Amazon one costs 30% more. And that's the reason why it selected this N1 high CPU 8 on Google, even though the other two or the earlier two nodes were on Amazon. Remember, everything works because I'm in the same region, so I'm within the 5 milliseconds that we talked earlier, and therefore this application works very nicely, even though it's sit across two different cloud providers, because they are within 5 milliseconds of each other and they're connected over VPN. And the story is probably the same on the E2 high CPU. I assume E2 high CPU 2 is cheaper than an M5 equivalent, or C5 in this case equivalent, because the on-demand price on Google is cheaper for that particular machine than it is on Amazon. Guys, it's not always the case. And there are regions, sometimes there are regions all over the globe where the AWS machine will be lower cost, or there are some example, especially on AWS in some new region, where the spot instance of AWS will be cheaper than the spot instance of Google. Hence the idea that when you want to beat the cloud providers and play them, break the monopolies, you can do this with Kubernetes. As long as you are within the 5 milliseconds, then you can create an autoscaler that is smart, that will compare the prices. It doesn't do much in that, right? It sort all the machines by pricing order. It only select the machines that are required. That's why I have an 8-core CPU here and a 2-core CPU here. And it takes the first one on the list, the first one that is available. And if the container is spot friendly, then we'll select the spot instance. If the containers are not spot friendly, so typically if they are singleton, so if they have only a replica of one, then it's not good to use a spot instance, then it will use on demand. So I assume this is why I have some on demand here and I have some spot instance here. If you go back to my workload, I have 111 pods and they all sit in a cloud provider, in a node. They're all scheduled. There is no more pod that is unscheduled, and so everything has been provisioned. So that's an example of what you can do. It's a little bit of a prototype because I wanted to show you that it's possible to do an arbitrage between two cloud providers within 5 milliseconds of each other if you can create a cluster that span across more than one cloud provider, and then you add an autoscaler that is smart in the sense that you just sort the prices for the machine it needs, take the first one on the list, and deploy that one. The only issue you may have with this is now you have containers that span across two locations. They have to communicate to each other, and therefore you will start to pay egress cost between them. So now you have AWS that wants to talk to Google. It uses the internet, the VPN, even though they're very close to each other, you are still paying for it. So you're doing the arbitrage on the CPU side, but you are penalized by the cost of bandwidth that is now increasing because you have some traffic that goes between Google and AWS in real time, and it's happening right now. You don't really know what this container do. So the autoscaler is not smart enough to know that one has more traffic than the other. It will just do an arbitrage on CPU cost. But if you factor egress or the cost of traffic, then the change of the arbitrage may not be the same. And if you think of the cost of egress, and you think of doing this as an arbitrage of resource, in the financial world, we call this a transaction cost. So you're able to play the market in the sense that you can buy a compute instance where they are cheaper, but you are having a transaction cost to do this, and the transaction cost is the cost of bandwidth. And so you should only do it if your cost of bandwidth is lower, the increase of the cost of bandwidth is lower than the money you make on selecting a machine that is a lot cheaper. Here we have a lot of room, and we're talking of 30% price difference between two cloud providers. And this 30% is OPEX. So every month or every day, you have a 30% advantage in compute on this cluster that is mitigated by some traffic between AWS and Google for this application. Now, this optimization that I've done, I'm using an optimization for CPU. We actually have a product like this, but we don't optimize across two cloud providers. We do a lot of optimization within the same cloud provider because you already can save a lot of money just by doing this. But this is kind of the extreme of what you can do in this financial arbitrage by deploying a Kubernetes application across these two cloud providers. If you guys are interested, and then I will take question, you can go here, cast.ai/startup. You can book a meeting, and I will go over with you some of the prototype things that we put in place to do this, and how we created the cluster across two cloud providers, how we created a VPN automatically that is strong enough so that if there is an outage, it will recreate itself. So we apply the same concept of Kubernetes to the infrastructure itself. And the last thing I want to say on this is sometimes it's not a financial arbitrage that you want to do. It's a disaster recovery arbitrage. So think of this as, if you go back to my example here, where I have my two cloud providers and my four nodes, if suddenly Google has an outage, so if these two nodes here disappear, it doesn't really matter because the autoscaler knows that and immediately recreate a node, a new one or two new ones, but it will recreate the two new nodes where it can. So if Google goes down for any reason or has no capacity in US East, then the autoscaler will just take the same idea, right? It will sort the list of all available machine by price. It will just happen that there is no machine from Google, and it will just use AWS in that case. So this idea of deploying across more than one cloud provider is relatively robust to a disaster recovery. If there's a catastrophic failure in one cloud, then the nice thing with Kubernetes is it will automatically adjust itself and recreate all the missing nodes in the places where it can. Because that doesn't work very well for data storage, so you have to be a little bit more careful there, but it works really, really nicely for any stateless application. So you are kind of guaranteed that your app continues to run even though one cloud provider had a catastrophic failure. Even if the failure is for only 5 minutes or 10 minutes, your app should still be up and running. That's why we love Kubernetes so much. So that's what I wanted to show you guys. And again, go here if you have any question, if you want to book a meeting, and I'll go over this or other optimization that we do. That's all I wanted to show you. So the conclusion here is, yes, the fact that you have monopolies in cloud is not great, but yes, also the use of Kubernetes is giving us some hope that applications are portable, and even pieces of applications can be portable, especially when you have a stateless application where you create a cluster that span across more than one place, that is smart enough to select the right machine according to its prices and according to its availability between one cloud and another. And then remember that you have a lot of places you can choose from, because in fact, they are all 5 milliseconds away from each other, especially a big blurb in Frankfurt, another one in London, US East, US West, Sao Paulo, Singapore, Japan, South Korea, Australia, and India. And there are a few more that are coming to South Africa. So that's what I wanted to show you. Thank you very much for your time. And if you have any question, please feel free to ask me.
All right, awesome. Thank you, Laurent. Much appreciated for that. Looks like we have got a few questions already lined up. So for anyone else who's got questions, make sure you click on the Q&A tab right now to type in what have you got to ask. But we'll open up with Valentinus, who says, is there, when you're talking about autoscalers, is there any core example of those? Things like GitHub,
Yeah.
GitLab?
Yeah, I wish we could show it. Valentinas, it's probably a good idea you ping me offline, and I'll give you some tips on how we did this. We did it as a prototype, so meaning we created the VPN ourselves. We use open source to create the cluster. I show you some UI because we did build some UI for other things, and I was able to reuse it. But our UI is not supposed to be for this. It's just monocloud. It's a monocloud product that do cost optimization. But because I trick it, the cost optimization algorithm was able to recognize more than one place. And so instead of using AWS 1 and AWS 2, I trick it to use AWS 1 and Google 2. And so that's how it happens. So yeah, ping me offline. I'll tell you.
Okay.
Another question, what will happen to infrastructure on passive cloud? Let's say I choose Google Cloud over AWS 7 Compute. Will this tool destroy my gateway, load balancer, network after moving my application? No, it doesn't. At least not the way I built it. So the way I built it is I created a cluster. I just created a VPN between AWS and Google, and I told my master node where it can find nodes. But you notice that when the cluster was empty, I was only using Amazon.
Mm.
But Google was ready and it was in standby. It was ready, meaning the autoscaler knew it could go to Google if it wanted to based on price difference. But I could very well have said, I don't want to go to Google, but I want Google to be available in case I need it. And
Mhm.
so that's more of the disaster recovery idea. And so in this case, everything works. The VPN works. The Mastodon is already aware of what it can do, but it's being told not to go to Google. But is if for some reason Amazon stopped to be available, then it will look for the disaster recovery procedure and suddenly use Google because AWS is offline for some reason. So you can play with this if you want. That's kind of the idea. So
Okay.
you don't pay for what you don't use. Yeah.
Okay. Looks like we've got another question. One from Vitaltis. He asks, "Are there any drawbacks in using multi-cloud solution with Kubernetes?"
Yeah, it's a great question, Vitotas. So drawbacks in using multi-cloud solution with Kubernetes, I guess if you are using, I'm just reading, I guess if you are using RDS database on AWS on the private network, it would not really work if your application would run on GKE, since it would not be able to reach your RDS database. Yes, you're absolutely right. I am not using GKE. I am using an open source version of Kubernetes. It's actually very similar to kops. And therefore, this cluster is fully aware of the services of Amazon and the services of Google. You see, the cluster actually doesn't really know that it rocks across two places. It just knows it's a cluster. The cluster is connected over a VPN to the entire AWS services and over the same VPN to the entire Google services. So if you use RDS, then it will actually work. Even if the node or the container that needs RDS sit inside Google, that container doesn't even know that it sits inside Google. It just sees the service as any other services that Amazon provide because it sits on the network that have access to them, the same way as they have access to Google. Some, I would say, high-end GPU, most of the time GPU-based compute, they could use these because GPU happen to have better services on Google for some time. So you can use that for some ML compute and then use AWS for your regular application. So you can really play around this, around these ideas. Again, it's a prototype, right? So it's early in the days of using this, but at least I wanted to show you that you can use Kubernetes, and these are some of these advanced use of Kubernetes where you can start to play this pricing difference, or you can play this backup and restore solution, but it's an online backup, so you don't even know there is a backup. There is no backup. It just happened to live in between two things. Or you can also say to AWS you don't like them anymore, or to Google that you don't, or to Azure that you don't like them anymore, and then you click a button that says, "Dear autoscaler, don't use them," and suddenly you see all your nodes moving to the other. Yeah. So you can go far into this. We haven't played too much in this direction. We tried that. We simulated catastrophic failure, and yeah, you can even have a master node that is replicated between Google and Azure or Google and AWS. So even if the master node goes down on Amazon, doesn't really change anything because you have the other one. Anyway,
Okay. Wow, that was some interesting insights. So yeah, I see where you come from. Like I think the kind of regular pattern here has been, Kubernetes. It's very early days. We're still trying to figure out the mastery of it, and who's going to be leading the way with that. And by the way, if you guys did enjoy what you heard from Laurent, or you want to ask him some more questions, or you think some more questions, there are means to contact him by. Feel free to use those. I'm sure he's open at all times to conveying with the rest of you. But I think we'll bring this talk to a close. Thank you very much, Laura. It was a pleasure. And folks, do stay tuned because in a few minutes, we're going to have our keynote speaker to close out day number 2 of the conference in just a few minutes.
thank you guys. Thank you, Darren.